Hello everyone, welcome back to SAT Math Question of the Day with Professor Brothers Chaiken and Joel, Seth's brother. We're here to hopefully show you how to study for the SAT and also how to approach doing specific SAT problems. So in terms of studying, sign up for an account with the SAT or sign up for a Khan Academy account and get to the SAT digital practice. If you want to see how to do it through the SAT account, watch our video that's dated June 29th. So without any further ado, today we are doing one of the advanced problems in solving systems of linear equations. Oh, advanced. Okay, please try to do it. Pause it, come back, and we'll be here. Okay, in the above system of equations, A is a constant. For what value of A does the system of linear equations have infinitely many solutions? Wow, this is an algebraic. Got to do a lot of algebraic manipulation here, don't you? With negative signs and distributing. I mean, don't you have to get both equations in the same form? Annotate. Wait, how do I? Boy, annotate. Okay. Don't you have to get both forms of the equation, like ax plus by is c, and then compare them? Doesn't that seem like a reasonable first step? It may be yeah, wow. Okay, so then this is negative 6x, and this is a 24. Here you really have to be careful. Wow. And this is an 8x, and this is a minus 72y. And this is an equal sign. So you have to move this 6x over to get 14x by adding the 6x. Wow, there's only one y, which is negative 72y. Now the constant is just plus 24. It is so easy to make mistakes in these problems. Wow. Look, and I even obstructed this. Oh boy. So that's a 7x. And that's a minus ay. And that's equal to a 16. Boy, what a weird 7. Wow. Yeah. Well, you would divide the first question by... First of all, it's pretty clear you would divide the first equation by 2, right? To get 7x minus 36y is equal to 12. And that's good. Look at this. Things are coming out. Oh, and you want infinitely many, which means these equations have to be the same. Hold on a second. How are you ever going to get those equations to be the same? Is there a mistake here?
I think so.
There's got to be. So you got to go back. But there's a mistake with the constant. There's a problem with the constant. Right? Let's just check the constant. This is clearly a plus 24. And this is clearly a 16. Now, What about this 14? Did I make a mistake? 6x plus 8x is 14. And 3x plus 4x is 7.
Yeah. Well, we could check it by writing, that if A is 36, the second equation is 4x, minus 36y.
No, it's 7.
4x minus 36y.
You get the 4x. It's 7x.
No, I know. Okay. Equals 16 minus 3y. And the equation above it is 8 times x minus 9y. Right?
I'm not sure where you're getting any of this.
I'm just copying the equations from the beginning.
No, but that's a 3x here. That's not a 3y. That's a 3x.
Oh, it is?
Yeah.
All right. A minus 6 times x minus 4. All right. Now, so simply set x and y to 0 and see what the see if no, that won't work. infinitely many solutions, infinitely. So we
They
want
have to be
that
the same
whatever the first
equation.
equation is satisfied, then the second equation is satisfied. Okay.
The two equations have to be the same, literally the same. You have the same 7x. If you
Well, not
force this to
literally.
be
This
a
a
36,
multiple. They have to be a
yeah,
multiple of each
they have
other.
to
A
be a multiple of
non-zero
each other.
multiple of
Right.
each other. Yeah. Okay.
Uh,
So, well,
uh, but what's going on here? There
uh,
must be some sort of really incredibly stupid mistake. What about this 8? This is a problem with this
well,
8.
now let me check your
Wait, there's a
arithmetic.
problem. There's a problem. There's a problem. It's 8 minus. It's 8 plus 24. This is a 30.
Oh, okay.
No, no, no. This is a 32. This is a 32. So this is a 16. Okay, fine. So we're done.
Wait. Six
We're
times
done. We're
four is
done. We're
20.
done. We're done. We're done. I forgot the 8. I forgot the 8. It's 8 plus 24 is 32. 32 divided by 2 is
Oh,
16.
I know
So
why.
A is
I know why you
36.
forgot the 8.
Yeah.
Your silly eyeballs.
Yeah, my
Your
silly
silly
eyeballs. Yeah.
eyeballs
Yeah.
saw this 8 and this 8, and you canceled them. That's why I thought it was 24.
I didn't cancel them. I purposely.
Well, I believe that this was 24.
Yeah, yeah, yeah. So you
But
let.
I believed it was 24 because I mistakenly saw that this 8x as an 8, and I canceled the 8 here with the 8 here, leaving a constant in the equation of 24 on the right, which was wrong.
But
So 8 and 24 is 32. Right, there we go.
right,
So
yeah,
multiply the second equation by 2, and you get 14x minus 2a equals 32. So 2a equals 72. A is 36. It makes the two equations equivalent.
equivalent, right? Yeah, yeah, yeah.
Yeah.
So notice the approach.
Of course, they might have, so this is uh, this method. This method, uh, well, assumes that the problem that the SAT gave you was, shall we say, well posed,
Of course, yeah,
was feasible. If one of these numbers, like the 4, if that 4 were a 3.5, then it would be a different character.
yeah,
The two equations would then either have a unique solution, or they would have no solution at all.
right.
So let's talk about geographically. The situation where linear equations have a unique solution is when the lines representing the equations are not parallel, and in Euclidean geometry, non-parallel lines cross, and the common point is the coordinates are the unique solution.
Right.
But there are two other possibilities: that the two lines are parallel.
Yep.
Okay? And two lines that are parallel, one of them has the equation ax plus by equals c. And the other one has the equation kax plus kby equals kc plus something extra.
Right.
But the extra is non-zero. And the other case is when the two equations are equivalent. And when they're equivalent, the two equations, the graph of this of the solution set the graph of each equation is a straight line, and those two straight lines are the same straight line,
Right.
right? And in that case, the algebra and the algebra, the two equations have a form, as I said up here. Ax plus by equals c, and kax plus kby equals kc, where it's where a and b are not both zero. Similarly for here, if they're both zero, we would have a different case.
Right.
And here k is non-zero, otherwise you get an equation that's trivial. Now, there are a few other possibilities. What if a and b are both zero? Then you have an equation 0 equals c.
Right.
How many solutions does that have? It depends upon what c is.
Yeah, of course. If c is 0, there are infinitely many.
Yeah, and the whole plane is a solution set.
Yeah.
If c is not 0, then the solution set is empty.
Right. So,
what if you have one equation is 0 equals 0, and the other equation is ax plus by equals c, where a and b are not both 0? Then the solution set is points that are either everywhere, but also satisfy the second equation.
Right.
Which are the points that are satisfy the second equation?
Yeah, which we talked a little bit about.
If the equation here were c equals 0 equals 9, then even with this equation, the solution set is nothing, the empty set.
Right. So I have a whole different sort of approach to what we're talking about. First of all, it's nice when you have something like this just to divide out the greatest common factor. When you see equations, polynomials, anything, and there's a greatest common factor, just pull it out and get rid of it. Just divide everything by k, and then the equations really are the same. When the equations, as I see it, really are the same after you've taken out the greatest common factor, then you know that there's only one equation.
Are they the same before you take out the common factor?
Yeah, I know, but it's more explicit.
Well, they are the same in the sense that their solutions are the same.
Okay, I know, but that have them look the same. Okay, this way, it's like have them really look the same by taking out the greatest common factor. Then you
all right. Here are two equations that look the same. 9/10 x plus y equals 3.
Okay.
And 9x plus y equals 3.
No, they don't look the same because the
just a little.
Yeah, I know, but just a little difference makes a big difference. It's like a factor of 10. Yeah, that's the difference between having a penny and $1, or between having $10,000 and $100,000.
Yeah, it looks the same. A lot, a lot of you have 1 followed by 7 zeros versus 1 followed by 8 zeros. They look the same.
Come on. Anyway, I want to really suggest something that really is important here. I mean, the stuff said really it's all theoretical stuff. But what happened in this problem with us? Particularly with me. I started doing the problem and I hit a theoretical impossibility. Right? I found I got a problem here when I did it the first time because it was impossible to do. The theory just slammed up against the reality. So when that happens, you have to say to yourself, you made a mistake. Yes, occasionally the test will make a mistake, but 99.9% of the time it's you.
I think the rate of mistakes on the test is a lot smaller than 1 in 1,000.
Right. So in other words, when you run into a theoretical problem on a test, and it's, by the way, it's important to know the theory, right? Because if you know the theory, then you realize something is really going bad. Then it's your responsibility to find your mistake. And it took us a
Yeah.
while to find it. But we knew there had to be a mistake. There just had to be a mistake in this problem. It's just a question of how long does it take us
That's
to
because
find.
these are SAT questions.
Seth, I know, but that's what we're doing.
SAT questions are not
Seth, 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 Seth,
real
Seth,
questions.
Seth, let's think of it as conditional probability. We have a big if statement. If we are doing SAT questions then, so forget about the other case, okay? Forget about reality. Just we are in the SAT zone. We are if you're doing an SAT question.
Well, I'm looking forward to leaving the SAT zone when the video's over.
Okay, fine. You will have that opportunity to do it. But when you're in the SAT zone and you hit a theoretical problem and you hit a problem which is impossible to deal with, you made a mistake.
It's not impossible. It says when you run into a calculation that reveals an inconsistency.
Yes.
The inconsistencies are not impossible to deal with.
Okay. Okay.
What's impossible to deal with on the digital SAT is that you're in the middle of the SAT, right? You're taking it on your computer in school, and boom, plop, plop, your computer explodes.
Okay.
You have a fire in your lithium-ion battery.
Well, there'll be proctors, and people will be able to deal with that. Okay?
I wonder if the proctors are going to be prepared, are going to be given training to what happens if somebody's computer catches fire.
Yes, I think people can handle it. I think
really?
Anyway, let's get back.
They can handle it. So what's going to happen is they have to evacuate the whole school building.
Let's get back to this. Anyway, we're very lucky this wasn't a multiple choice test. There could have been a multiple choice question saying that something like it's impossible to answer this question. That would have been nasty. That would have been nasty because then you would say to yourself, wait a second, did I make a mistake or what's going on? So we're very fortunate that this question, the way this question was worded, we ran into a theoretical impossibility because the way we first did it, it was impossible to get infinitely many.
Yeah, well, they could have asked the question. They could have said the question is give the numerical value of A for which the system has infinitely many solutions, or write none.
Right.
If there isn't any.
That's right. That would have been But by the way, so do you notice this is a little? Don't you think this question is a little bit more theoretical, just the way it was worded, and also look at how complicated these equations are.
Yeah.
Don't you get a sense this is a slightly harder?
Yes, it seems harder.
Than the non-digital SAT questions that we've been doing for a year.
Yes.
Yeah. So you got to be ready to do a little more.
They're making them harder.
Yeah, you got to be ready to do a little bit more algebra, and you have to be able to understand a little bit more theory. Which hopefully we're really Seth and I are really into the theory stuff, understanding the fundamentals behind the problem. So hopefully we will give you some of those approaches, and think that way when you're doing these problems. When you're studying, think like what the theory is behind these things. What's the abstract? What are the concepts behind these problems? Okay, so should we see what they did? They probably simplified the equations. They probably made them look like this. But let's see what they did. So, okay, clear all drawings. We said it was 36. I think that was what we said. Okay. Wow, look at that. How did they answer the question? They did 5 steps, a new all-time high so far. System of equations, everything many solutions. If every pair, okay, fine, okay. If we graph the equations, the 2 equations represent the same line. Let's put the equations in standard form. Very good. Notice they're not making any stupid mistakes. The second equation is, they're divided by 2. Fine, okay. Yeah. What we did really, but you're really going to, okay, fine. Divide by 2, that's fine. Okay, that leaves us with 2 equations. Therefore, 36 and 2 equations represent the same line, and the system of that infinitely many solutions. Okay, so pretty standard way of doing it. I mean, what we did, I know what I did, although I made a mistake, is before I divided the first equation by 2, I first got the first equation. Because you may have to have multiplied one of the equations by 2. Um, you didn't necessarily know, but I see what they did. They tried to just get this in the lowest form. They took the GCF out, which is not a bad thing.
Notice that
They did.
the question was to find A.
Yeah.
The question is not. It's not find the coefficient of y.
Mm.
Of course, coefficient of y depends on the constant that the equation would be multiplied by.
Mm.
But notice that they asked for A, and they gave you the equation in which the A appears as a coefficient of y on the left-hand side with a minus.
Yeah. Yeah.
So you have to make sure that you actually answer the question and give it. So we got 36. The second equation is 7 minus 36y.
Right.
Equals 16. The common equation is 7 minus 36y. They gave you 7 minus ay equals 16, and the question was, what is A?
That's right. Yeah. Yeah. That would have been really
so a mistake a mistake that one might make is to, having seen that this term here is minus 36, to put in the answer box. Minus 36.
Right, if it was a multiple choice test,
they
probably would have put minus 36 as a choice.
Yeah.
But that would have been really nasty if they asked for a coefficient instead of the A.
Yeah.
Yeah.
Mm-hmm.
Okay. So I guess that's it for today. No, I don't think we should do another one because we spent enough time on this, and you also went through and described when equations have when set of equations have one solution, no solutions, infinitely many. So plus we blew it. So I think it's time for us to get out of here before
Are they ever going to give us 3 equations and 3 unknowns for the situation?
It's possible, but they're not going to be full blown. Maybe one of them would be A is 3, and then you have to solve for B and C. It's possible. We'll find out. Okay, everyone, have a great day. Tomorrow is Throwback Thursday, so hopefully we will do a Throwback Thursday question. And keep just practicing. Just keep practicing questions. Okay, everyone, please like us, dislike us, give us comments on our YouTube videos, or email us. Email us SAT Math Questions at satmathquestionoftheday@gmail.com. And we hope to see you tomorrow. Take care, everyone. Bye. Stop the share. And we will stop the recording.